This is my custom mechanical keyboard called PHNX. It is based on the Miryoku layout and features 54 keys, including one additional row at the top and a few macro keys. Each key has an individual LED that can be controlled using the QMK software. Stay tuned to learn more while I go through the schematic, the board layout, and the build process. Jumping into KiCad, let's take a look at the schematic. I've decided to use a USB Type-C connector which requires pull-down resistors on the CC pins for power negotiation. We are pulling 500 mA on the V-bus line, which should be sufficient to drive the microcontroller and the LEDs. Then we have the differential data pair D- and D+. As we can notice, the Type-C connector has one pair for each data line. Because Type-C is a reversible connector, we are going to connect each pair together to be able to use the USB in both orientations. We can leave the SBO pins unconnected and we'll talk more about the shield later on. Proceeding to the USB protection and power filtering, we start by connecting USB LC6 TVS diodes to protect the board from electrostatic discharges. We are filtering the noise from the power line using this pi network and a bulk capacitor. We are also using a 500 mA fuse, which should prevent things from blowing up if you have a short in the circuit. Lastly, I included one LED to indicate power. It is advised to leave the shield floating if you don't have a physical metal enclosure, but I have decided to put footprints for one series resistor and capacitor, just in case we would need them later on. Now we can proceed to the microcontroller. For this design, I've decided to use the Atmega 32U4, which is compatible with the QMK. On the power line, we have one bulk and three small decoupling capacitors. The reset line is pulled to ground through a push button, which will reset the microcontroller if we need to flash it externally. We have a 16 MHz crystal with two load capacitors, the V-bus pin directly connected to 5 volts, the USB data lines, each connected with a 22 ohm series resistor, and the UCAP pin connected to a 1 microfarad capacitor. I have exposed the SPI pins with an ESP header, just in case we need to externally flash the microcontroller. Then we have an addressable LED data output line connected on PB7, HWB pulled to ground through a resistor, and another LED on P6 which we can use to illuminate our logo. The rest of the pins are used for the keyboard matrix and they have been reorganized to fit the physical routing of the board, which we will see later in the video. Now we can take a look at the keyboard matrix. We have 12 columns and 5 rows. If you want to learn more about how a keyboard works, make sure to check out the video from Joe Scotto, which I will leave a link in the description below. In addition to the typical Miryoku layout, we have some macro keys and an extra row on the top. We can decide how we want to map those keys later on. It is also important to include a diode on each switch in order to prevent key ghosting if multiple keys are pressed at the same time. The LEDs are split into two different sheets to make the schematic more readable. To control the LEDs, we only need one data connection from the microcontroller because we are using addressable LEDs. Let me show you more about how we connect and use them. Here we can see that each of the LEDs needs power supply. The data from the microcontroller connects to the first LED, which is connected in series with the second one. The second is connected to the third, and so on. The way those LEDs work is that each can be individually addressed using code. So when we send some data from the microcontroller to the fifth LED, for example, the first one will get the data and pass it on to the next one until it reaches the fifth. When the fifth LED gets the data, it will change according to the instructions we sent. Even though addressable LEDs are usually more power hungry, we don't need additional components on the board, such as the LED driver required for regular LEDs. Lastly, we have the mounting holes. I've decided to use 4 size M2 and another 4 size M3. Because we have LEDs and each requires power supply, I have decided to use a 4-layer PCB to simplify the routing process. Starting from the center, we have the Type-C connector with the rest of the components for power protection, filtering and shield grounding. Next, we have the microcontroller with all capacitors positioned next to the power pins, the reset button and one of the more sensitive components, the crystal. I've tried to place the crystal near the microcontroller and maintain equal length for both lines. Below the crystal we have the ESP programming header and the LED, which will illuminate the logo printed on the top cover. Lastly, we have the 4 M2 mounting holes spread across the middle section to secure the board in place, with a small cover on top to conceal the components. On the top side of the PCB we have MX Cherry compatible footprints, each equipped with one addressable LED soldered on the bottom. We also have 4 M3 mounting holes on both sides of the keyboard to further secure the board to the bottom case. I plan to conceal these screws later during the design of the 3D parts. If you want to explore the board's routing, you can download the source code and open it in KiCad 8. After designing the board, it was time for manufacturing. I've started by exporting Gerber files which are needed for the manufacturer. In KiCad we do this by navigating to File and then selecting Plot. Here I kept all the defaults and I've included all of the layers which were pre-selected. Then I chose the output directory and I pressed the Plot button. We also need the drill files, which I generated by selecting Generate Drill Files. I only adjusted the output directory with the same directory as before, and I generated both drill and map file. The last thing I needed to do is to compress those files in a single zip file. The manufacturing of the prototypes was sponsored by PCBWay. They have excellent customer service, cool PCB colors and fast shipping. Besides their advanced capabilities for PCB manufacturing, they also offer services such as PCB assembly, 3D printing, CNC machining and much more, which can help you manufacture products ready to sell. Make sure to check them out for your manufacturing needs. Here I started by going down to the PCB prototype. I chose Quick Order PCB, which measured the board automatically after uploading the Gerbers. I've uploaded the previously zipped file. Here we have plenty of options to adjust, but for this board we can keep the defaults. I personally prefer using white or black solder mask as I like the clean look. We can also choose different surface finish and via processing, which can additionally improve aesthetics and quality, but will also add cost to the final product. When I was done, I saved to the cart and finished the ordering process. After just a week of placing the order, I had the prototypes ready to be assembled. The boards came wrapped in a foam and were firmly secured in a protection bag. I received 2 more boards from my original order, which I can only thank PCBWay for. I gently cut the protection back and took a moment to admire the quality of the PCBs. Unfortunately, I haven't ordered a stencil, so I just put paste on every pin and hope to get good results later. Then I started placing the components. To help me identify the position of a component, I opened KiCad and looked at the placement in the PCB editor. The whole process took me around 14 minutes. For reflow soldering, I used a somewhat unconventional method. I still don't have a reflow oven and using this method can damage the components, but I decided to take the risk and in the end I was happy with the results. I did the final retouch with a soldering iron and some soldering flux. We now have a partially assembled keyboard with main components in place. I quickly connected it to my computer and I was really happy to see it shown in the device manager. I flashed the QMK software and only then started experiencing issues with USB resets. It took me a few days of debugging and playing with fuses to fix the issues. I also had to desolder the resistor on the HWB pin. Now the only way to put the microcontroller in bootloader mode is to use the magic key in the QMK software. Because it was time to test the switches, I also soldered all of the diodes. Here we have Outemu Red MX compatible switches and SK6812MINI-E LEDs. The seller also included some different test switches. Before starting with the soldering, I quickly tested shorting the pins to ensure that every diode was properly soldered. I also designed a plate in Fusion 360 to hold the switches and I started placing them one by one. I had to redesign the plate a few times to get the clearance right, but in the end I was happy with how it looked. Next I flipped the keyboard and started soldering the switches. We need to make sure that every pin is properly inserted. At the moment of assembly I didn't have any spare keycaps, so I had to take out the keycaps of my PHNX Q66 and place them on my keyboard. We need to make sure to put the LEDs in the correct orientation, because taking them out once they are soldered is going to be difficult. The short leg on the LED is indicating ground, while I have marked the power pin. This can be tricky and I will make sure to correct that in the next revision. I started placing all of the LEDs on each key. This once again is a repetitive process and we can jump to soldering. After placing all of the LEDs, I soldered them in place and played with the QMK to make the correct adjustments for the LEDs I used. I still have quite a bit of work to do in the QMK to make use of all of the keys and further optimize the configuration. If you would like to contribute, check out the GitHub link in the description below. I completely skipped the process of designing the 3D parts. They can be found in the repository of the source code. I personally think that the case can be improved, so feel free to play with it. I will be giving away exactly this keyboard to one of you. All you need to do is hit the like button, subscribe to the channel and leave a comment below. If you would like to support me, you can head to my website and buy one kit for yourself today. I hope you enjoyed this video and see you in the next one.